Hi everyone, I'm Shubham. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2019 Paper 2 Mathematics, and the question for this video is this. For non-negative integer n, let f of n is equal to sigma k equal to 0 to n sine of k plus 1 by n plus 2 pi sine of k plus 2 by n plus 2 pi divided by sigma k equal to 0 to n sine square k plus 1 by n plus 2 pi. Assuming cos inverse x takes values in 0 closed to pi closed, which of the following options is or are correct? There are 4 options and it is a multiple correct type question. So essentially here, if we can find f of n in terms of n, we can comment upon the answers. Now to solve this question, we would be in need to have the formulae for sum of sine series and sum of cosine series where the angles are in AP. So for example, sine A plus sine A plus D plus sine A plus 2D plus so on and so forth, suppose there are n terms, then the summation we can write as, in a concise way, in a simplified form, sine of number of terms multiplied by common difference of angles divided by 2 multiplied by sine of first angle plus last angle in this sequence of angles A plus D, A plus 2D, so on and so forth. The angles are in AP. First angle plus last angle by 2 divided by sine of common difference of angle by 2. Similarly, cos A plus D plus cos A plus 2D plus so on and so forth. The sum of n terms we can write as sine of number of terms multiplied by common difference of the angles by 2 multiplied by cos of first angle plus last angle by 2, where first angle last angle are respectively the first and last angle of the sequence of angles which are in AP, A plus D, A plus 2D, so on and so forth, divided by sine of common difference of angles by 2. Now you can also note that in the two formulae, only this term, the second term of the numerator, is different in sine and cos. Rest is the same. So let's solve this question. So here, to possibly be able to use what we have just now seen, I should be multiplying numerator and denominator by 2. So in numerator, 2 sine A sine B essentially becomes cos of A minus B minus cos of A plus B. So cos of A minus B or B minus A is essentially the same thing. Why? Because cos of minus theta is cos of theta only. So what you get is cos of pi by n plus 2 minus cos 2k plus 3 by n plus 2 pi divided by sigma 2 sine square theta I can write as 1 minus cos 2 theta. So basically it becomes this. This whole summation, and k varies from 0 to n, and so below also it varies from 0 to n. Now if you see carefully, the numerator, as I add or as I add these terms, cos of pi by n plus 2 is not varying with k. So basically this will add n plus 1 times and it becomes n plus 1 times cos of pi by n plus 2 minus. Now here it is again a cosine series, the formula of which we have just now seen, where the angles are in AP. So the summation would become sine number of terms, which is n plus 1, common difference, which if you see carefully is 2 pi by n plus 2. So common difference by 2, it will become pi by n plus 2. Cos of first term plus last term by 2. So first term would be what? 3 pi by n plus 2 when you put k to be 0. Last term would be 2n plus 3 by n plus 2 pi when you put k to be n. So essentially you can say denominator is n plus 2, pi is also coming common, and the first and last term as you add, the numerator would become 2n plus 3 plus 3. So 2n plus 6. And mind it, we have to do first plus last by 2. So it essentially becomes n plus 3. Whole divide by, we also have to consider one more term in denominator, which will be sine of common difference by 2. So common difference is 2 pi by n plus 2. By 2 becomes pi by n plus 2. Now here the denominator would become 1 is being added n plus 1 times, so it becomes n plus 1 minus again the sum of cosine terms where angles are in AP. So here it becomes sine of number of terms times common difference of angles by 2, which essentially is this. Because common difference in angles, as you vary k, it is 2 pi by n plus 2. So by 2 it becomes pi by n plus 2. Cos of first angle plus last angle by 2. First angle is, you put k to be 0, 2 pi by n plus 2. Last angle you put k to be n, 2 times n plus 1 pi by n plus 2. So here as you add, you'd get n plus 2 here and pi here, and first plus last in numerator would give you 2 plus 2n plus 2, basically 2n plus 4. By 2 we have to do, and it becomes n plus 2. Divide by sine of common difference between the angles by 2. Here if you see carefully, n plus 1 pi by n plus 2, essentially you may see this as pi minus pi by n plus 2. Check it out. You can write n plus 1 as n plus 2 minus 1. So essentially it becomes pi minus pi by n plus 2. And sine of pi minus theta is sine theta only. And if you see carefully, this is exactly sine theta if I see pi by n plus 2 as theta. So this term and this term will cancel out. Similarly, this term and this term would cancel out for the same reason. Also, here n plus 2 and n plus 2 is cancelling out, and what you are getting is cos pi, which essentially is minus 1. Cos of pi is minus 1. And similarly, you may see n plus 3 by n plus 2 pi. N plus 3 you may see as n plus 2 plus 1. So n plus 2 by n plus 2 would become 1. So essentially it becomes 1 times pi plus 1 by n plus 2 times pi, which is pi by n plus 2. Now again, what is cos of pi plus theta? It is minus cos theta. Yeah. So essentially what you may expect is, if you see a bit carefully, numerator becomes n plus 1 times cos of pi by n plus 2 minus cos pi by n plus 2. So essentially it becomes n plus 2 times cos of pi by n plus 2. And what about denominator? It is n plus 1 minus 1 effectively. So basically it becomes n plus 2. So this essentially becomes, which is f of n, is cos of pi by n plus 2. So effectively we have got f of n to be cos of pi by n plus 2. So it looked such a a big huge term, but it has come out to be a very googly bush simple term. Now let's explore the options. Here we have got f of n as cos of pi by n plus 2. So what about f of 4? You put n to be 4, you get cos of pi by 4 plus 2, which is 6. Cos of pi by 6 is indeed root 3 by 2. So this seems to be correct. As n tends to infinity, pi by n plus 2 would tend to 0. And cos of 0 would essentially be 1. But it's given half. It's incorrect. Now, what about f of 6? F of 6 essentially would be cos of pi by 8. And cos inverse of cos of pi by 8 would be pi by 8. So essentially alpha becomes 10 of pi by 8, which essentially is root 2 minus 1. Now if you just manipulate, alpha plus 1 would be root 2, its square would essentially be 2. So you get alpha square plus 2 alpha plus 1 minus 2 becomes minus 1 equal to 0. So indeed alpha, which essentially is 10 of pi by 8, which essentially is root 2 minus 1, satisfies this equation. And what about cos inverse of f of 5? F of 5 is essentially cos of pi by 7. And cos inverse of cos of pi by 7 would be pi by 7. And 7 times pi by 7 is pi. Sin pi is indeed 0. So this is also correct. So that means my answer should be A, C and D. Thanks for listening. Stay tuned for the next question.